It's time. Welcome everybody for this presentation called How Often Should You Check Your Site? And it's a practical guide. I'm really looking forward to hear about it. We have Noshnika that is going to present for us. And yeah, let's start. I'll let you introduce yourself. I'll be monitoring the chat. And if you have any question, never hesitate to ask in the chat or in the Q&A. And we'll get to you at the end of the talk.
Yara, thank you so much for saying hello on the chat. By the way, thank you so much. This is How Often Should You Check Your Site, a practical guide. I'm Noshnika. Very quick introduction. So I'm a DevRel person and coder. I've been working with observability tools for about 10 years. Started all the way back in the day, right at the birth of New Relic. Back when the main New Relic site was still called rpm.newrelic.com, which stood for Rails Performance Management, because the very beginning of observability was so tied to observing Rails systems. So way back in the day, at the time, right, that I came on, they monitored 10 different languages, right? So it wasn't still married to Rails, but that was the subdomain that we used for the dashboards. I currently work with the people at Checkly that does automated synthetics. It's not a Checkly pitch at all. We're just going to talk about how we do checks of our service, our system, our site. In fact, I should have maybe called this, right, how often should you automatically check your site? We all know that we go to our site, to our service, we all go and send pings to it, we go and see if things are going on, but this is all about automated checks of various kinds. I've had a couple of great conversations, along with my industry experience. In the last 6 months, I've kind of asked these sorts of questions of a number of industry people and had really good conversations, especially on Reddit and Hacker News, with people working in shops talking about what cadences they set and why, and what tools they use to monitor and why. And so I've come back with some pretty interesting information. I think I have a couple of quotes from people on Reddit in the presentation, which is nice. If you have any questions during the talk, feel free to hit the Q&A or the chat. I tend to be, having worked on Twitch and YouTube Live and stuff, I tend to be someone who will pause and answer questions live, but obviously we'll get some time for that at the end. So very briefly, this talk is in 4 parts. We have talk about diagnosing downtime, which is a very short piece, and then we'll talk about the cost of downtime and the cost of monitoring. I bring up this canard now, it'll come up again in this section, that when I have conversations with people, I say, hey, why don't you do this kind of monitoring? Very common response is, well, sure, if money was no object. Right. So the fact is that the cost of monitoring are a significant component. Then we'll talk about how we check our site or service. We're going to talk about API checks as well in that. And then we'll have calculated the right cadence. And it's no surprise here, right, that I often talk about a website because I'm old and that's sort of where my mind goes. But obviously, right, so many of us are working entirely on mobile apps, entirely on inter-system, like software as a service systems, where an API is what we're actually checking. But the analogy remains the same, right? This is not about checking particular pieces of JavaScript loading in a front-end page. This is about, hey, is our service working or not, right? So let's start there. Diagnosing downtime, along with the classic don't use the office Wi-Fi. So we've all been there where we have little reports that maybe we have some kind of problem, and we've all taken out our phones, turned off Wi-Fi, hit the turn off Wi-Fi button, maybe hit the VPN to make sure we were really hitting from an outside IP address, and then gone and checked, hey, is the site up or down? And in fact, when I went and asked people, hey, what is the first thing you do when you when someone reports to you that your site is down? I gave people on Reddit a fairly detailed scenario. I said, you have a person who works in sales who you really trust. You know that they're not just on bad hotel Wi-Fi or something. You know that they know what to do. They know to check the web console. They know to check a few things. And they're saying, hey, is production down right now? What's the first place you look? Very interesting. People's responses were, well, it's obvious. Everyone does this. And then they would give a completely different answer than everyone else gave as to what was the very first thing that they would look at, right? All the way from application logs to I go and check the site directly, to everything in between, all kinds of automated tools or other systems in between. That's the first thing I check. And I think that's interesting because I think, that first component is, of course, the first section of our time to resolution on a service. So the fact that everybody's going into a different place shows that there really isn't one perfect answer to knowing whether or not a service is available. David, thank you so much. Okay. David says to host and panelists, robots save lives, which they absolutely do in this case. So three important ideas about monitoring and finding downtime. Uptime does matter. In fact, I was reading some of the first Google writings on their SRE book, and it's really quite amazing because at the beginning they say, well, what does uptime cost you? Well, look at how many sales you make per second, and then the number of seconds you're down, that's how many sales you lost, and that's what it costs you. And that's a little bit laughable now, right? Like if you're down for 2 days solid and you're a dating app and it's Carnival, right? What you lost was not 365 2 over 365% of your revenue, right? You lost a lot more than that, right? Everybody now knows that your service doesn't work anytime there's a busy time, right? So you could be out of business, right, as the result of a week-long outage. You're not going to lose 1/52nd of your revenue as a result of a week-long outage. So that one is a little naive, right? We know that in fact that the costs of downtime are larger than that. So how you find out really, really matters, right? If your users report downtime most of the time, right, you're developing a reputation for unreliability. And then finally, right, users won't keep downtime a secret. Back before what happened to Twitter happened, before the recent unpleasantness, right, we would always say that like most users, 90% of users, whatever rule of thumb, will report downtime to Twitter before they talk to you. Right. In fact, most people will never contact you. They will just go on Twitter and say like, boy, this service is so unreliable. Look at this funny error message I got, that kind of thing. That's what's going to happen first. So again, how you find out about this downtime really matters, because you can even have downtimes that you don't find out about like at all, right? Until something else happens and your system heals. So, okay, we know downtime is expensive. And of course we can quote these numbers and say it costs you trillions of dollars per millisecond to be down and all that thing. And so of course, that happens. Something we're going to address a little bit later is how there is actually a danger in going too far this way and going all the way over to, well, just no downtime is acceptable. There's a million no downtime is acceptable. We don't really talk about the costs, the full costs of that attitude, but these things do happen. Let's talk about the costs of downtime and the costs of monitoring. So my husband is a machinist. And, I was very interested to learn how things are measured and created. He was asking me about how you copy over significant digits in the right scenario. This is when he was in training. And one of the things that we came to, because I had worked with scientific equipment before, was like, hey, if you have a tool that is only accurate to 20 meters, and you measure, oh, well, it used to be 200 meters, now it's 205 meters. What you need to write down is that the length didn't change, right? Your tool is too inaccurate to tell you that there's been a significant change. And even when working at the smaller scale, we have what are called tolerances for the variation in a part between the part and its actual measurement in reality. And he's absolutely had people come back and say, you produced 1,000 of these parts and 2% of them are rejected because they're not to tolerance. Can your shop stop doing that? Can it move to a state where there's no rejected parts and there's no mistakes? There's nothing missing. You're never inaccurate. And the fascinating thing about that is that going from, for example, a 5% rejection rate to a 2% rejection rate is a completely possible thing to do. And it has an increased time budget, but it is absolutely deliverable. It changes the budget, but not massively, right? However, when you start to say, well, how can you have no mistakes? Suddenly the speed that shop works at drops massively, right? It starts becoming, instead of, well, if you want a lower rejection rate, it's going to take, 10 or 20% longer. You start saying, hey, to have no rejections, it would take us as long as it would it'll take 10 times the amount of total time to have no rejected parts. And a similar thing happens for us, right? When we start saying, hey, we can have zero downtime, I think we all know what the natural corollary of that is, which is that the thing that you're going to lose eventually through that policy is any kind of speed of delivery of changes, right? When you say, well, we really, 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 really want to know that any change to our system, any increase in scale, any shift of our system is not going to cause downtime, you start saying, well, just don't change anything. And we're all used to, or any of us who've worked in enterprises are used to seeing these messages go out across all teams saying, hey, no changes are allowed to the Orca 3 system ever, right? Stop making updates to the Orca 3, whatever it is, whatever system it is. Stop making any changes to that system because the downtime has become too unacceptable here, and we're pushing to zero downtime. And of course, then the result there is obvious, right? Obviously, no features will be implemented in that. No tech debt will be handled. No performance problems or scalability problems are ever going to be addressed. So we can see that that's a failure state. However, when the system goes down, right, the costs can be huge. And you can have people come in and say, hey, because you failed, even though the failure was very, very short, it was during a sales demo for a $1 million ARR, which means your 10-minute outage cost us $1 million for sure, right? And, hey, I work in the DevRel space. I've worked in support space. I've worked with salespeople, right? I understand, right? You're frustrated that this happened, right? I would say maybe multiple things resulted in us not getting that sale, but I get the argument where you can say, I'm going to set a budget of this crazy high number for even very short downtime. So how could you not, when you're talking about tools to monitor your service or check if your service is up or down, how could you not set those always to the absolute max? And this is, remember, is where we started, right? As we're talking about calculating and finding a cadence for our service to be monitored. How could you not do that at the absolute max? Do you have $8,509 a month to just make sure that a very basic site, we're talking about a site that sells novelty shoes, stays available? And you think, well, that's crazy. In fact, when I talk about numbers like this in social media, people are like, well, I went and checked Datadog and they have, $12 for 1,000 checks. So, like this $8,000 number, that's just way, way out of line. You're never going to hit that kind of budget. Well, let's talk about it. We have a site. It has just 16 page routes. So not a lot, not a whole catalog, not a complicated site at all. We want to hit it from 4 regions because we'll get back to this, but hey, we've had it go down just for Germany, just for Austria before, right? And we do not want our Austrian customers being like, hey, you've been down for like 2 weeks. No one uses your site anymore, right? So now we want to check every 4 minutes. And I don't dive into this really far here, but it is a question of, hey, this is the very first chunk of resolving a problem, right? This is just the time it takes to go from we even are aware that we have a problem at all, right? And so, yeah, very good. And so, 11,080 pings per month, right? It sounds crazy, but you're saying, hey, how long do you want to wait before you even know your site is down? If you want to wait 10, 15, 20, 30 minutes, right? Then how you're actually always going to find out that your site is down, which is always going to be from users, as we referred to before, right? But if we want to say, hey, I think that if the site has been down for 5 minutes, I can hear about it from an automated system, and the user might not notice, might just come back and check it again a few minutes later, we'll be fine. So, this is a very reasonable cadence, right? So that's 70,009. My comma's in the wrong place there. So actually, I don't know what my math is doing in that one. I'll DBD on that one. I know my math is right. I use a little whole number integer math on this, so not sure quite the number I'm thinking of there. Wait, can I do it? 11,000 times 4 times 16, 70,912. So I've got an extra zero there at the end. Apologies. But right at the rate of $12 per 1,000 pings, that's $8,509. So that's just for a very simple site. So this kind of monitoring is not free. The Datadog pricing is relatively high, and we'll refer to that. But it is not that you can just do whatever monitoring you want. And when you talk about automated monitoring, prices need to be considered. Obviously, there are examples of very, very simple automated monitors that will get you like pretty good results. People have little node apps and stuff that just go ahead and reach out automatically. But those still have real costs of maintenance and running, and what they do is more limited. Let's talk about this geo-monitoring thing, right? If you frequently experience failures in just one geographic area, you need to spread out your tests. Great number of attendees, by the way. Thank you so much for joining. A little late, talking about figuring out the right cadence with which to monitor your site. If you frequently experience failures in just one region, you need to spread out your tests, meaning you need to monitor for multiple regions. This is an extreme example. You probably are not going to monitor from all these regions, but you at least want 4 or 5, right? Pretty definitionally, because you can generally expect that there are things that will happen that will take your site down for a single region. So let's talk about just to hit forward back. What did I do here? Yep. Okay. Let's talk about monitoring an API with API monitoring, right? Which sends a simpler curl request and so is a little bit cheaper to get from a service like Datadog. How does that do on this same standard, right? Well, let's say we have maybe 32 endpoints we want to hit, which is not unreasonable. We want to hit individual paths because we know that behind those multiple endpoints, right, is different microservices that are supporting them. We're not usually working in the monolithic code base, so we can expect that one might go down while others are still up. We have 4 different possible inputs for each, right? We want to try like a create, read, update, and destroy action, or we want to try other types of actions for each. And again, we conservatively want to have 4 different regions. And now we're turning our frequency up just a little bit because we really want to know right away when our API goes down, right? Let's say our API is being consumed by large partners, right? They're consuming at a very high rate. They may even have stood up their own monitors to keep track of our system. We want to know right away, right? So we set it every 2 minutes. Now we're at 11 million pings per month, right? Which is about $5,000 a month just to monitor that basic API. So again, Datadog's pricing here is a little high, but it still is the reality. This is not something that is just free or just you can do whatever. We're starting to talk about like the price of headcount here, right? Just to have a pretty straightforward monitoring solution. In these cases, right? This is a solution that is just loading the page, checking for 200, checking a couple values. That's it. So even that kind of simple monitoring, I wouldn't say simplistic, but simple monitoring, has an expense to it. Oh man, we're moving into part 3. We're halfway through our time. Oh, we're on the glide path, folks. We're doing great. Okay, so let's talk about defining what that service level agreement is to say, okay, this is how long we can afford to be down. I only have one slide about this because I will say at the most basic level, other SRE luminaries have said more and better than this than I have on it. Hazel Weekly is a great person to check out for this. There's basic documents from Google. There's the Dora Foundation's documents or the Dora Group's documents. Way back in the day, Puppet Labs wrote a bunch of great stuff. These are really smart people who can tell you how to do this. Currently, if you're working in an enterprise, a lot of you are going to have the situation that the SLA was something that got agreed to during a sales negotiation. But if the gods smile upon you, you will get to be part of that negotiation and get to say, hey, what's possible and not. And this question about what is the target cadence for your monitoring, it really should be part of that consideration of like, hey, what is actually possible? You can think about a contractual SLA, which again is this is the situation I'm talking about, versus a more dynamic SLA where you're saying, hey, these services, there's these kinds of expectations with it. You can say, hey, this is a very critical piece. Hey, this is a nice to have. You can look at your own system and say, how can we improve resilience? For just to take an example, let's say you have a music streaming service. You have like, hey, your friends are listening to this now, right? That social feed maybe is optional, right? You can say, let's set a lower SLA for that component, which means working with your front end group to say, I want it to fail gracefully when that service is down, because currently it does have a lower SLA than the rest of our service. But that's thinking about a dynamic SLA. And yeah, again, don't fall into no downtime. Don't fall into like, this just can never happen. We can never go down again. I will say, in conversations with people, most people end up at kind of the max frequency for site checks. I understand why. I think there's some nuance to it, but the fact is that that kind of no downtime, I won't say trap, but kind of thinking ends up with, okay, look, I'll stand up some node service. I will go and hit it every single minute, no matter what, and notify. And I don't think there's anything wrong with that. I think that what we want to think about more in-depth checks, as we'll look at in a minute, and we want to think about how, what is the cadence for those more in-depth checks? A simple kind of 200 okay response when you have multiple enterprise partners, you probably are going to end up having some kind of check that says, hey, does a 200 okay come back every single minute? Okay, let's talk about that, about the type of checks that you're running. Part 3, how to check your sites. Think about heartbeats versus synthetics versus end-to-end testing, right? It's very fun to plan out how we're going to have a beautiful test system that's going to let us know everything, even test-driven development that's going to like drive everything forward. It's going to let us know there's regressions, right? Writing the tests and actually doing the tests is a little bit tougher. I don't know if you all saw this. This is a very real thing, which is parents came to a Willy Wonka themed event, which was promoted entirely with AI imagery, and then they showed up, and the image on the right is what they actually found there. So it's tough, right? Sometimes it's tough to deliver what you conceived in the real world. So a brief note on the evolution of synthetics, which we don't have time to read. We're skipping this slide. as we grew into a more and more complex requirements for what we wanted to simulate with a service, Playwright is a project that grew out of those expectations to say, hey, I want to do stuff like clicking on a login button, logging into the site, receiving a response back, coming back and checking it 20 minutes later, checking that those two responses are the same. I want to make sure that this was present in the response, right? I want to parse the response either with the regex or with node-based parsing to find components and make sure that they're there. Back in the day, we had these like very, very simple checks to be like, hey, is there some matching text on the page? Playwright's gone a long way beyond that. There is some parity from some other projects. Playwright's not the end all be all. It's a very powerful contender right now. A lot of other stuff has not kept up. I will say, like, a lot of stuff's been acquired, stuff's being used by other competitors, and it's not necessarily the same depth. Playwright's free and open source, so have at it. If you're not doing any of this now, I check out Playwright. I don't need to give you a whole map of the industry, but Playwright can do really, really complex stuff. Here's an example of downloading a PDF, checking the suggested file name, making sure that it matches with what's expected. Right, pretty, this is exactly the sort of stuff that used to be quite difficult to do successfully with an automated system like a little headless browser coming from a virtual machine. Playwright can do some really, really sophisticated stuff. So Playwright can definitely stand in for like end-to-end tests, right? Where you can have Playwright scripts that written well with good locators continue to be stable for years and years and years and find pretty deep problems with your system even way after they were written. So Playwright can have real value for long-term testing and monitoring. I don't talk about it in a slide separately here, but the line between that kind of testing and monitoring has blurred a little bit. And this is part of the time I got the response of like, well, it'd be great to do this if money was no object, right? Where it's like, yeah, I'd love to run like full end-to-end tests every few minutes, but money is part of it. And taking a look at that a little bit, right? It's possible with a tool like Checkly or with another like Playwright running service to do these really, really in-depth checks that sort of would be familiar to us from testing land as monitoring, running them every minute or every few minutes. In this case, this is running a visual regression test saying, hey, I have a problem, and it's not just that a single locator on the page was different, but actually just the response looks visually different than what I've expected before. So that can be very powerful. And you might think, well, you only need to run visual regression tests, right? You only need to run them, when you're releasing new code. Think about how many third-party dependencies we have now. Think about the fact that your marketing team can drop arbitrary code into the header of your page, right? Like, you don't want to be checking every 15, 20 minutes to just say, hey, has anything changed visually about the page, and do I need to look into it? So yeah, this is just one example of where Playwright can take you very, very far and very, very into depth. Okay, we've got 4 minutes left. Let's talk about the meat of this, calculating the right cadence. It's really all about SLA math, folks. It's not a one hand, the other hand thing. It's pretty straightforward. It's SLA math. So let's talk about a couple of calculations there. So you have 7 hours is your monthly downtime budget, giving you a 99% SLA, right? You're expected to be up 99% of the time. That means 7 hours out of every month you can be down. Takes about 2 hours to get your system resolved. That's your mean time to resolution. And notably, if you don't have these numbers, we don't know what your SLA compliance is now, then you're going to struggle to calculate this stuff. But that's a separate presentation. How about getting there? You have about 2 incidents a month, right? This just tells you how long you have to detect incidents. In this case, it's 90 minutes, right? That's the longest time a downtime can go undetected. And so that's probably a good cadence for a really in-depth set of checks to say, hey, we want to be running these checks every 90 minutes to really know if the service is completely working, e.g. a Playwright test that goes, logs in, does an account action, attempts to undo that account action, and then does some kind of invalid account action and comes back and says, hey, I get back the correct invalid that, you permission denied response to that request. Let's tweak it just a little bit. Same budget, same mean time to resolution. Now we've got 4 incidents a month, right? Now you just have 15 minutes to detect that problem. And that's from the problem being detected by the problem occurring to the problem being detected by the test service to a human being becoming aware of it. So that may not be your pinger rate, right? That may be that you may need to go a little bit above that if you're using a round robin system of notifications and it's taking quite a while for the thing to get acknowledged. This is your mean time to resolution calculation can vary a little bit depending on that time. But yeah, very, very real. Here's a meme based on my real life, which is taking down staging with the integration test that you meant to prevent that. So, all right, here's the Reddit quote, folks, and it's really the key of this stuff. I'm gonna send a video of this to this Reddit user because I really love this. It says, if that calculation results in an unreasonably high cost, you'll need to do something else, like build a more economical way to get a health signal. So that's like running your own self-hosted system. I don't have a link here. I'll share it on my Twitter and on the Checkly Twitter as well. There's a really great couple of homebrew solutions. Again, run it on your own VM to go and check your service. Build a more economical way to get a health signal, improve the mean time to resolution, e.g. maybe you need to be able to deploy rollbacks faster or renegotiate the SLA. So you can imagine that with these numbers, you can get a negative value out, right? You can say, hey, how much time do we have? Well, we got to detect everything about 8 minutes before it happens, right? If your mean time resolution is too great, if you say, essentially, you can do this calculation and say, hey, we're violating SLA every month now already, right? And so even knowing the instant that something goes down is not going to work, right? Right? You get these situations where they say, hey, we can never, ever go down like that again, right? Postmortems and taking responsibility are all well and good, but you need to monitor at the right rate to find problems before you violate SLA. As this same Reddit user posts, this is the last sentence that really stuck with me. Choosing to probe at a rate inadequate to defend your SLA is planning to fail. And as I said in my first wrap of this, if I go into battle for pinger checks, I would definitely fight under the banner of choosing to probe at a rate inadequate to defend your SLA is planning to fail. Okay, that's been my time. Again, I'm Noshinika. You can find me on Twitter at serverless_mom. I used to be serverless mom, but the takeover, the recent unpleasantness, I lost that account. So it's serverless_mom. Sonia, I think we're still mutuals on there, so don't worry. I think we're good.
Yeah.
It's been about 2 years. It's about 2 years I've been on the new account. Thank you again to the Checkly team who helped me write this presentation and help me with some of the technical demos in it, and also, of course, give me the morning off to come and do this talk. Yeah, but now we've got 2.25 minutes for questions.
Yeah, listen. Thank you so much. It was really, really interesting and a really a logical framework to go about it. So I learned a lot. And also I see we're working in the same B2B industry because there's a lot of I could relate on the negotiation that sales team have to go through, the marketing, doing that change on the website. So there's a lot of story that,
It's very funny when people reply to these things and they say things like, well, ideally you'll know the problem like this. And then I just reply like, hey, well, is that how you found out about your last downtime? No, the last downtime was reported by users, but ideally that wouldn't happen. It's like, well, I agree. I agree that ideally it wouldn't be the case. So let's talk about how we deal with the real world situations that we all have to deal with.
I have a question on the geographic distribution. So how do you decide on that? Imagine you're like a big shop that sells things internationally. How would you go on choosing the number of location?
So, it is possible to do like really, really highly distributed checks. I believe that at Checkly, actually, I'm not going to say the number of geos that are available because I'll get it wrong. There are some things to consider there. If you're really, really frequently experiencing single geo problems, if that's like the norm for you, maybe you're dealing with a ton of data sovereignty stuff. So there's a ton of differentiation between the regions. Then you want to think about, it's not so much deciding on the number of regions. I think it's a better question to ask, should you be doing round robin checking with those geo regions, or should you be doing parallel checks? So round robin checking is, we check every 5 minutes or every 1 minute, but it's one region at a time. So it's, North America, Europe, then South America, then Africa, then East Asia, then South Asia in that order. So in fact, how often does a check come from North America? Every 12 minutes, every 20 minutes, right? Because you're rotating through all those locations. If you're really frequently experiencing single geo failures, then you may want to think about parallel scheduling, where those were my examples, which was kind of trying to grab extreme examples where the 4 or 5 geos that you picked, you're pinging from them every single minute or every single 2 minutes. You're hitting all of those regions at once. So I think that's a bigger question than like which geo should you do? So the geo answer is partly just the engineering of public cloud tools, like what geographies are going to be available to you, and then secondarily is where are your business priorities. Like you may not need to ping from Beijing, or you may not need to ping from Europe if you're a ride hailing app and you're not available in that country. So yeah, I think that's where you start with your selection of geographies. But the bigger question is just how do you time that kind of distribution?
Makes sense. Thank you so much. So we are
of course, that was a
end
great
of the
question.
time. I have your Twitter. That's the right one, right?
Yes, thank you so much. Thank you.
Yeah, I found it. So please go follow her. She's awesome. And we're really happy to have you here. And the talk is going to be available on replay. So no worry for people that came up late, or if you want to share it with others, no problem. It was really insightful. Thank you so much. And
thank you so much for coming, everybody.
Let's go to the next session. Have a great rest of the conference, everybody.